Hello YouTube, so today we're going to have a look at how to differentiate y is equal to 2 to the power of x. Okay, so the first thing that we need to do is use the power rule, okay, in our rules of logs. So what is the power rule? Okay, power rule, power law, doesn't matter, same thing. So y is equal to 2x. The power law is simply taking the exponent of the base, so in this case it's 2, and our exponent is x. So what we're trying to do by the rules of logs is put the exponent in this case, okay, which is the x, to the front of the equal sign. So, sorry, not the front of the equal sign, in front of the base, by means of logging. Okay? So what that means is, if I just move this down here, is that we end up with, if we ln by both sides, okay, I'll do it in steps, it's easier. I'll do ln y is equal to ln of 2 to the power of x. Okay, that's lnning both sides. Okay, that's lnning both sides. Then what we do is we take the exponent on this side, so that's still 2 to the power of x, and we bring it down. So we end up with ln y is equal to x ln 2. Okay? Ln y is equal to x ln 2. So now what do we do? Now we find ourselves in a position where we can differentiate. So I'm going to do it in this kind of manner. I'm going to say, okay, fine, we have that, we know that that's the product of something, that's x dot, so I could say that's x dot ln 2, which means x times ln 2. So the clue there then is that we can use the product rule to differentiate this part of the equation, okay, x ln 2. Zoom in there for you. Okay, there we go. So we could differentiate with respect to y, and we are. Okay, in this case we are, because you'll see it makes sense later on. But for now, I'm going to differentiate with respect to y by neglecting the ln y itself. So okay, the product rule. Product rule was first introduced if you're doing A-level mathematics in C3. Just trying to sort out the stability problem, but that's my carpet. Well, so the first, the product rule was introduced back in C3. Okay, if you're doing A-level mathematics, you might have seen it somewhere else if you're doing a different course. I don't know. However, that's beside the point. The way that I remember it is, y is equal to uv. Alright? Y is equal to uv. So now the question is, what's u and what's v? Well, we could say that in this case u is x. So we could say that u is equal to x, and we could say v is equal to ln 2. Okay? Right, so now we need to differentiate them. Okay? So we get du by dx is equal to 1, and then v is equal to ln 2. Okay? So the question remains, how do we differentiate that? Well, we have seen this, we've come across this before, okay? Where ln 1 is 0, ln 2 is equal to a value, okay? So ln 2 is equal to a value, I don't know. So ln 2, if I type that into a calculator, is equal to that, okay? Let's just get that in focus. Okay, 0.69314 71806. Okay, and to prove it, there you go, ln 2. Okay, so we know that that's equal to that value. So now what happens if I type in ln 3? Ln 3, 1.098612289. Right? Here's the proof. Ln 3, 1.098612289. There we go. So obviously, as we type the number in, okay, so we keep going up in small increments, say 1 of 1s. Okay, so now we go to ln 4, 1.3862943661. Okay, 5, etc., etc., etc. It keeps increasing. So that gives us a clue as to say that, okay, if that number increases, then the gradient must also increase as well, isn't it? I mean, you know, if you plot a graph of those values, say y is equal to ln x, where x is the increment, so basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, on the x-axis, y, you know, is y. So then, if we draw a table of that and we plot it, then we'll see that the graph itself is increasing. It's going exponentially up. Well, not exactly exponentially, but more or less in that fashion. Like, so it will look something kind of like this. So if we just kind of draw axis there, something along this kind of line, something similar to that. Okay, that's y equals ln x. I'm not going to write that there because I need the space. Okay. So now that we've got that out of the way, and now we understand what that is, so then by rule of thumb, okay, if we differentiate v is equal to ln 2, then acknowledging that that's a number, and if we treat it as a number, then we should find that v, dv by dx, is 0, because you can't differentiate a number, because any number that you differentiate is 0. So dv by dx is 0. Okay? So now, if I move the camera down, hopefully I've got enough space, then our product rule, our formula, is, here we go. Okay, and the way that I remember it is from y is equal to uv, remember? So our product rule will be dy by dx, okay, is equal to u dv by dx plus v du by dx. Alright? So, just in case this is unclear, okay, that's dy by dx is equal to u dv by dx plus v du by dx. Okay? So now, if we go back and see the numbers that we've found, okay, from this equation, we have found that u is equal to x, v is equal to ln 2, du by dx is equal to 1, dv by dx is equal to 0. So now, what we need to do is put those values into this equation. So, dy by dx is equal to u, which is x, dv by dx, which is 0, plus plus v, what was the value of v? Ln 2, and du by dx, which is 1. Okay? So now, what does that give us? That gives us ln 2. Alright, because this is a multiplication. Okay, so for those of you who don't know, I'm assuming that you do, but If you don't know, then this is a multiplication, so it's x times 0 is 0, obviously, with the addition of ln 2 times 1, which is ln 2. So we get a final value of ln 2. Okay? So now, if we tidy that up, we get dy by dx is equal to ln 2. So, let's tidy that up. Okay? So now where do we go from here? Well, that part's done now. So we've essentially what we've done is we've differentiated. Okay. Let's see, where is it? No. So we've differentiated this part of the equation. We've differentiated this part of the equation. We haven't differentiated this part of the equation, bearing in mind that y is equal to 2x. Okay? So what we need to do, because y is equal to 2x, we can differentiate it. So putting it into perspective, so basically putting that into perspective, what we achieve, okay, putting that into perspective, is that we have, just putting that down here now, ln y is equal to x ln of 2, and we get, okay, 1, okay, with respect to x, okay, if we differentiate with respect to x, cool, we get 1 over y dy by dx is equal to, okay, let's see, so we have, yeah, so we get, that's exactly what we get actually, sorry. So differentiating that side of the equation, okay, the ln y is equal to x ln 2, we achieve this. Sorry, ln y, if we differentiate that, what I'm trying to say is we get 1 over y dy by dx, right? Because if you look in your textbook, it will say ln x differentiated is 1 over x. So applying that rule, what we get is 1 over y dy by dx. It makes sense, doesn't it? So what we need to do is put 2 and 2 together, and we should end up with an equation that looks like this. So 1 over y dy by dx, okay, 1 over y dy by dx is equal to, oh, blimey, that's strong, ln 2, okay, because is equal to ln 2, because if you remember, we differentiated the right hand side of the equation, and that gave us ln 2. So I'm going to put that as a dot. So 1 over y dot dy by dx, that's just, the dot just symbolizes the multiplication. It gives us ln 2. Okay, so now if I multiply both sides by y, there's a strong stench from the pen. Okay, if I multiply both sides by y, you will get dy by, just going to move this down slightly, dy by dx is equal to y ln 2. Okay, dy by dx is equal to y ln 2. So y, okay, was equal to 2 to the power of x. So therefore dy by dx must therefore be equal to 2 to the power of x ln 2. And that's the proof. Okay? That is the proof that proves that a to the x ln b, alright, is equal to dy by dx when you have something, alright, that's equal to, when something is equal to, what did I say that was? Yeah, so when y is equal to a to the x, basically. Alright? So that's what that means. And I hope you've learned something today. That's been better. And what to expect? Well, I am multi-tech spec now, and yeah, I hope to see you again soon. And I'm gonna try and prove one of the other equations. It was something to do with sine and cos, why they are what they are. So you know, when you differentiate sine, why do you get cos, and that kind of thing. I have to review one of my older videos, because in my older videos, what I had was you can see my beard in my older tutorials, even though it was on paper, and it's a bit clearer than this, but it's the same thing basically. Well, similar. So yeah, I hope you learned something today. I've been multi-tech spec, and see you again soon.